We've got a sort of double SOH problem here. The length we're asked to find is the blue length down here. Now, we only know one fact about this triangle, so that we cannot apply SOH yet. However, we do know two facts about the yellow triangle. And using those two facts, we can find the length of the common length AC. That will give us two facts in this triangle, which means we can find the blue length. So let's find the red length first in triangle ACB. So with respect to this angle, 41 degrees, we need to know an opposite, and we've got a hypotenuse. This means we use the sine version of SOH. And let's call this height h. So I can say sine 41 is equal to the opposite, which is our unknown h, divided by 6.8. And h turns out to be 4.46, 1, 2, and on it goes. So we now look at the other triangle. Let's call the length we need x. Now, what is the relationship here? We've got an angle, and if we look out from that angle, yes, we've got the opposite, and we need the adjacent. So the relationship we need here in the second part of the question is tan. So I can say tan 55 degrees is equal to the opposite, and that's divided by our required value x. And again, if you pop that into a calculator, you get that x is equal to 3.1237. They need the answer to correct to one decimal place, which is here, and so therefore x is equal to 3.1, and that is to 1 dp. And that's your answer.